Howdy, this is Jeff, creator of Fingers Gestures. A new feature that I've added is image recognition for gestures. Now this is not some advanced AI, this is kind of a quick and dirty yet highly performant solution to try and recognize shapes and images in gestures. In the demo script image and demo scene image, I have pre-populated this giant array of gestures for different images. We have check marks, lightning bolts, single horizontal line, single vertical line, diagonal line, bottom left, top right, diagonal line, top left, bottom right, circles, the letter U, the letter V, the letter X. And I probably spent about 30 minutes to an hour fine-tuning these to try and make them as accurate as possible and to avoid false positives. It's not perfect, but it's pretty close. So for a game where you want to do a gesture to perform a spell or some action, I think this is a very performant and quick and dirty solution that actually would work pretty well. So let me show you this in action. In the demo scene image, on the left is going to be what it recognized, and on the right is going to be where you draw. So let's draw a check mark. There's a check mark. You can see it took 1 millisecond, and that's before the data was even cached. So let's hit escape and draw that again, and now we're down to 0 milliseconds, which means it is measured in microseconds. So we're doing pretty good. We had diagonal lines, both directions. We had vertical lines, horizontal lines, circle. I think we even had lightning bolt. And I think we had the letter X. There's the letter V, the letter U. I think that was all of them. UVX, circle, diagonal line, horizontal. Okay, yeah, that was all of them. So you may be wondering, how the heck did I do all this? And I'm going to start this thing over from scratch. So I'm basically going to delete all my code here temporarily. So when you load this demo script image, if you want to do your own and get rid of all these, simply clear out this dictionary here. Actually, I'm going to comment it out because I don't know if I checked my code in. So just going to comment that out. Okay, so now there's no gestures in the dictionary here. So now let's try some gestures here, and nothing should work because I got rid of all the gestures that I had spent my time making. Okay, so no match. So what I did is I started with the check mark, and I knew there's lots of check marks people can do. You can do a very vertical looking check mark, a semi-diagonal check mark, and a very horizontal check mark, and kind of variants in between, as you can see. So basically what I did is I picked up the first check mark about as vertical as I thought would be reasonable, even almost straight up. Yeah, so I started with that, and I say copy script to clipboard. You can go back to you can stop Unity there and go back to the, actually a faster way to be to use Notepad++ and just paste this in. So now you have the script for that gesture. You don't even have to stop Unity, so you can do a lot of these in quick succession. I'm going to do another check mark a little less vertical, copy it to the clipboard. I'm going to make another one a little less vertical than that, and so on. So let's try and do this quickly. Actually, let's go that way. And put him in the list. Maybe one that's pretty vertical. And that's a good first set of check marks. Now I spent more time going over this, but let's put these in. So we do this array. Now this is a dictionary, so each of these needs to be a key value pair with a gesture and string. So this is what you'll be doing when you make your game in your own custom gestures. And the last check mark. So once you have a basic set of gestures down, it's pretty easy to iterate. Here's basically the strategy that I've taken. So we have all our check marks. that we think will represent a pretty good range of check marks somebody could possibly draw. So now I start drawing check marks. Right away I notice that I missed a check mark, so I'll copy that to the clipboard, stop Unity, paste in my check mark. Don't worry about all these hex codes, these are just the bits of each line of the image that it calculated from the gesture. And I'll iterate again, and I will keep drawing check marks until I'm happy with the match rate. So that one worked, that worked, that worked. Now I'm hitting escape to reset the drawing. So I'm getting a pretty good match rate on check marks. One thing that is interesting and why I had those diagonal gestures is because sometimes a diagonal line can represent a check mark, because it matched pretty good. It doesn't have the slide hook here, but it matched. So what I ended up doing is I made several angled diagonal lines, like that was a diagonal, that was a diagonal, that one, that one, that one, and that one. And I ended up plugging all of those in to this diagonal line, bottom left to top right. So now it matches diagonal line instead of check marks when you do a diagonal line. So that's a strategy you can use if you find that there's a certain gesture that's close to what you want, but it doesn't look like it, and you don't want people to be able to do an action with just a diagonal line. You want them to actually have to draw a check mark. Then you can make a bunch of gestures that are just discard gestures where they match a certain shape that's close to another shape, and you can just throw it out in your game. In this demo script, I'm going to go ahead and put this code back to the way I had it. You can see I have an image gesture recognizer. So if you've used these gestures before, this is a new gesture recognizer called image gesture recognizer. So when the scene starts up, I say the maximum path count is 2. That's so that I can draw an X. If you are only ever going to have images or shapes that have a single path, you can set that to 1, and that way when the user lifts their finger, then they're done and whatever they drew is the final shape. Here's the updated method, very similar to the other gestures. Whenever the maximum path count is exceeded, for example, if I draw 3 separate paths, that's too many because I've set the maximum path count to 2. You can get called back to do something like reset before they can do the next gesture, and I think that's what I do when the maximum path count is exceeded. And that method is somewhere. Let's just go to definition. There it is, right above me. Of course it is. So yeah, I reset all the lines. Okay, and then the last thing to do, of course, is to add it to the finger script, just like you do in the other gestures. Of course, you also want to assign all the possible matches, which is what I'm doing here. I say gesture images is a new list, and I pass all the keys in from this giant array that I was pasting in earlier. You can see it's a dictionary of image, gesture, image, and string. So here's the image, gesture, image, which is basically this giant array of longs that represent the bits of the calculated image. And here's the 16, which is the width in pixels. That's kind of what I determined was a pretty good default for speed and quality of detection. You can actually go up to 64 for that width to get much higher fidelity and quality, but it also makes it harder to match things. So if you were trying to match a check mark of that high quality, you'd have to have a lot of check marks to handle all the possible angles and stuff. So that's why I picked 16. It's a pretty good balance. You'll have to find what works for you in your game, but if you leave it at 16, you'll probably do okay. Let's go over to image gesture recognizer. There's a lot of optimized code here, but I think the part you will care about the most is the public interface. There's that maximum path count we talked about earlier. The direction tolerance is basically a way to optimize out points so you're not dealing with hundreds of points. The user has to change direction in their stroke by this amount of radians in order to create a new point. So I think I've set it to 0.3, which is a little less than 1/8 of pi. So they have to change direction just slightly, and it'll start counting a new point for that. Otherwise it'll just extend the point out. The minimum distance between points is measured in units, which I believe is inches by default. The default value is 0.1, so a tenth of an inch. If the user's just kind of dragging their mouse really slow or holding it in place, then it's not going to create thousands of points. It'll just wait until they move the mouse more than a tenth of an inch or their finger on a touch device. The similarity minimum I've set to 0.8 as a default. That means 80% of the pixels have to match. That's something you can certainly play with in your training of your own gestures and images. That's just something I found to be a pretty good default, but you can play around with that. Gesture images are the set that you pass in. The image is what it calculated from the user's last gesture. The matched gesture image, if it found a match in this set here, then it will put it right here, the best match. And then maximum path count exceeded was that callback. And then you can also measure how long this thing is taking. This property will always be here every time the user finishes a gesture, and you can have a look and make sure you're performant. If you have thousands of gestures, which you probably won't, it's not really going to matter, but if you do have hundreds or thousands, you'll want to check that to make sure you're under probably a couple milliseconds to make sure it's real time for your game. Finally, I'm going to show you how to read the image. So I've got this update image function here. When the gesture ends, I call update image. And so for this, I'm making my own Unity texture. I'm passing in the number of columns and the number of rows. In fact, let's quickly go to those constants as well. So here we have a large list of bit masks. This is a way to restrict a long to only a certain set of bits. We have the image rows. This is probably the only thing you would consider modifying. Change this to a higher or lower number depending on how accurate or fuzzy you want to be. And then the line padding. A line padding of 2 surrounds every pixel with another pixel, so you basically get a 3x3 grid with 2. If you change this to 1, then it puts 1 pixel above and 1 pixel to the right. And if you set it to 0, then it does no padding of pixels. Okay. Finally, so I'm making this texture after each gesture. I'm looping through the rows and columns, and I'm looking at the image that was calculated from the stroke that I just did, and I'm setting the pixel of this texture. If it's 0, it's clear, otherwise it's white, which means that it got calculated as on. I apply and then set it. Finally, I check the match gesture image. If I didn't have one, then there's no match. Otherwise, I print out the string, so check mark or diagonal or whatever, and then I append the total time. So this is it's a really nice way. You can iterate very quickly to have a set of images. So if you had spells, you could have a lightning bolt, you could have like an X or a cross for healing, a circle for a protection spell, or maybe you want to do some letters or runes, or however you want to do this. Go to town, and please email me your feedback, jeff@digitalruby.com. Let me know what you think of this. It's my first stab at this, so I don't know how it's going to work for you. I hope it works well, but if you run into things or have suggestions, please send me an email. Thanks. Bye-bye.